thing disjoint sets does is equivalence classes. Okay, you can think of, because that's what everything in the same set is in the same equivalence class. Okay, so that's one of the ways of viewing disjoint sets. And what is this problem asking? It's asking equivalence classes. Whenever you say A equals B, you're now saying A and B are in the same equivalence class. And now when I say B equals C, I'm saying C and B are in the same equivalence class. And oh, by the way, by transitivity, C and A are in the same equivalence class. Okay? But that's great. It's a union operation, right? They're in the same disjoint set. So you're going to do, find A, find B. If they're in two different disjoint sets, call a union, right? And so basically what you're going to do in this program is you're going to do that for all the equalities, and you're going to ignore the inequalities. And then you're going to take a separate pass through the data, and now you're going to call find on each of these. And if they're in the same disjoint set, your answer is 0, false. If you get through it without, then your answer is true. Okay? So, what's the running time of that? Well, n's going to be in there because we're running through n. So what are we doing? We're running through n. Let's just say half of them are equalities, half of them are inequalities. So we're going to run through n, and for all the equalities, we're going to do 2 finds and a union, right? Potentially a union, right? Find O of inverse Ackermann and union O of n. I'm sorry, O of 1. What's n? N is actually going to be the number of distinct variables, okay? So the first pass is going to be O of n inverse Ackermann m. And then the second pass is going to be 2 finds, which are both O of inverse Ackermann m, so it's the same thing. So your final running time is O of n inverse Ackermann m. Now if you wanted to say it was O of n, because inverse Ackermann of n is never more than 5, you get partial credit. All right. Will your interviewer understand inverse Ackermann or disjoint sets? Maybe not.
What's inverse Ackermann?
I'm sorry?
What's inverse Ackermann?
Oh, inverse Ackermann? Inverse Ackermann is weird. So Ackermann's function is Ackermann of 1 is 1, Ackermann of 2 is 2 squared, Ackermann of 3 is 3 to the third, Ackermann of 4, 4 to the 4 to the 4 to the 4, grows super fast. Inverse Ackermann is the inverse of that function. Right, so 1 is 1, between 2 and 4 is 2, between 5 and 27 is 3, between 28 and whatever the hell 4 to the 4 to the 4 to the 4th is 4, right? So basically, but inverse Ackermann of like 80 bazillion, quadrillion, bazillion, whatever that number is like 4 or 5, it's 8. So inverse Ackermann is an increasing function, but for all practical purposes, it's O of 1. Okay. So you must have not had me for 302. Because I teach this in 302.
It's also been a couple years.
It doesn't just have it all etched in their soul. I guess teach it 22 times and you will. All right. Good. Class over. See you all. Have a good weekend.